Same thing. Given the numbers, see the pattern, create the formula, massage the formula to look like the geometric series formula. Right? That's what I'm doing. We're all good up to this point? Okay, let's identify things. Right here, we have to see that's a geometric series. What's A for us? Careful, what's A? 1/10, right? Because look, there's a number in front of everything, right? 1/10 is the number. It looked like it was going to be 1 earlier, but once we converted it over to get the correct exponent up here, n minus 1, we actually created ourselves a new A. So our A is 1/10. What's R? 1/10 also, right? That's this, 1/10. Now, will this converge or diverge? It should converge because it says find the sum. But what is it that we have to check to make sure it converges? The absolute value of R. What is the absolute value of R? Well, it's less than 1 for sure, right? And if you look on this, it says that you will get convergence if the absolute value of R is less than 1, right? Which it is. Now, what does it converge to? It says it right here. What does this sum add up to be? What does the formula say? So this right here means we have convergence, and it's going to converge to A over 1 minus R, right? That's what it'll converge to. And we know what A is and we know what R is. Okay? So, what does this add up to be? 1/10 over 1 minus 1/10, which is 1/10 over 9/10. And if you reciprocate that, you get 9/10. No, no, you don't. 1/9.
I have a question on that.
Yes.
So if we look at the equation for R, 1/10 n minus 1,
Yeah.
wouldn't that technically be 1? If you plugged in a 1 there, it'd be 1 minus 1.
Wait, say if what?
The 1/10 raised to the n minus 1, below, just below it. That, isn't that 1?
1/10.
Because it's 1/10 raised to the 0. So that would be 1/10 to the 1 times 1.
Yes.
You're saying R is 1/10.
R is the number that's being raised to this exponent.
Okay. So it's not what that equals. Okay.
That's right. Okay, what do y'all think? Let's do another one. Okay, this one's going to look very different. You ready? Same principle, but it's going to look like a different problem. Convert to a decimal. Into a fraction. Convert to a fraction. .13535353535 repeated forever. I would like to know what that is as a fraction. How in the hell is this a geometric series? Okay, you ready? Here we go. This is equal to 1/10 plus 3 over 100 plus 5 over 1,000. I'm going to do it a little different though. 35 over 1,000. Because these are grouped like 35, 35, 35, instead of doing 3 over 100 and then 5 over 1,000, I'm going to go 35 over 1,000. And then what about the next group? 35 over, yeah, just add 2 more zeros to this, right? So now 100,000. Oh, wait, hold on. Yeah. I'm using place values. Tenths, hundredths, thousandths, 10,000s, 100,000s, right? Then plus 35 over Okay, do you all agree with that first of all? I mean, like this is what it is. If you just get on your calculator and do 35 over 1,000, you're going to get 0.035, which would account for those two numbers. If you do this over this, you're going to get these, and then we're just adding them all up. No questions? Okay. Got to see a pattern here. The only part that's repeating is the 35, 35, 35, right? So I'm going to next go to this. 1/10 plus, I'm going to ignore the 1/10 for right now because it doesn't follow the pattern of everything else, right? Okay, this is 35 over 10 to what power? Third plus 35 over 10 to what power? 5 plus 35 over 10 to what power? 7 plus dot, 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 right? Let's see if we can come up with a formula that will generate at least this part. Again, this part I don't know yet. So do y'all see it? Sum n equals 1 to infinity. Okay, what about the numerators? 35, 35, 35, 35. The whole time it's 35, right? And then the bottom is always 10 to a power, but the powers are what? Odds starting with 3, right? So this is 35 over 10. How do I generate the odds starting with 3? 2n plus 1. What? You hate this already? Yeah? Okay, well. There it is. That's it. So now we need to somehow break out our massager and make it look like that. Bring the 35 out. Okay, so this is equal to, let's see, 1/10. I haven't dealt with the 1/10 yet, have I? You want 35 out of the whole sum? I can do that. Okay, I can do that. And then what's left in here, I'm going to write it like this. 1 over 10 to the 2n plus 1. Do y'all agree with that? Pulled the 35 out, which made this 1 over that. And then if I rewrite that as 1/10 to that power, this on the 1 and this on the 10, you get the same thing. So I'm starting to get to an r, but I'm not quite there because that exponent needs to look like what? N minus 1, and right now it's 2n plus 1. Okay, you ready for some more? This is equal to 1/10 plus 35 sum n equals 1 to infinity of 1/10 times 1/10 to the 2n. Properties of exponents here. 2n plus 1, I can split that into 2, right? Like this. Okay. More. Okay, let's do this. 1/10 plus 35 over 10 sum n equals 1 to infinity of 1/10 squared to the n. Okay, what did I do there? Yeah, I took the 1/10 right here, right? And I just took it out. And that gave me the 35 over 10 on the outside, right? And then I had 1/10 to the 2n, which I realize is 1/10 squared all to the n, right? This to this power, you multiply those two powers, you get 2n, right? So I'm doing it kind of backwards. But what's 1/10 squared? 100th. So this is 1/10 plus 35 over 10 sum n equals 1 to infinity of 1/100th to the n. We're getting there because I need it to be not n, but what? N minus 1 So now the minus 1 plus 1. Pardon me? Yeah. Sum n equals 1 to infinity. Okay, so when I rewrite that, it's going to be 1 over 100 times 1 over 100 to the n minus 1. Now I kind of am skipping a step there. I'm not showing the minus 1 plus 1, but does everyone understand I did the same thing I did just a second ago? Minus 1 plus 1, then split it. And now, is that geometric? Yes, we're finally there. What's A? 1 over 100. What's R? So we're here. A is 1 over 100. They won't always be the same, by the way. R is 1 over 100. And is the absolute value of R? Is the absolute value of R less than 1? Yes. Okay. So it converges. What does it converge to? A over 1 minus R. Right? So now this equals, I'm going to come up here. This equals 1/10 plus 35 over 10 times, so 1/10 plus 35 over 10 times A over 1 minus R is the formula for that. So A is 1 over 100 over 1 minus 1 over 100. So A over 1 minus R. Has anyone figured out what just this piece turns into? Not as a decimal. I think it's 99. 99 over.
It's 100 over 99.
1 over 99.
That would be 199. 1 over 99.
1 over 99. So let's see here. We have 1/10 plus 35 over 10 times, okay, this becomes 1 over 100 times 99 over 100. Just getting common denominator between those two, right? And then you flip, the hundreds cancel, you get 1 over 99. So 1/10 plus 35 over 10 times 1 over 99. So this equals 1/10 plus 35 over 990. Just multiplying across. One last step. Just get a common denominator, right, between those two fractions. So I multiply the top and bottom of this by 99, 99, and you get 134 over 990. So someone on their calculator type 134 divided by 990. Tell me what you get. Yes?
What's the reason you didn't add the 1/10 and the 35%? You could have done it, or no?
Add these?
Yeah.
No, multiplication before addition.
Oh, okay.
Order of ops. So does that work? 134 divided by 990 is the decimal point 135353535. So look at this. This is actually kind of cool. Any decimal that repeats like if the decimal ever repeats, just keeps on going, whatever it is, whether it be repeats 2 things or 1 thing or 100 things, if it ever repeats, what does that mean? Which means it can be written as a fraction. All repeating decimals can be converted to a fraction. So what about pi? Pi is a non-repeating, non-terminating decimal. It cannot be written as a fraction. That's what makes it irrational. Rational numbers, fraction, ratio. Okay, we are going to obviously come back and do more. So what I would suggest you do for 8.2 I would look at least 7, 8, 9, 10, 11, 12, maybe the first 7 through 12. I think you could probably at least attempt it, all right? I'm going to turn this off real quick.